Good afternoon, everyone. We are team number 1, Rosendo, Hugo, Juan Jose, Jesus, Ruben, Jordan, and Victor, and our challenge has been to drive a small differential robot around a V-shaped track completely on its own. To succeed, we must detect the line marking and its traffic signs, decide the correct maneuver, and execute it fast enough to hit the 90 seconds lap target using only a board computation with no external help whatsoever.
To master that shape, we kept everything on board. An NVIDIA Jetson running ROS 2 receives the camera feed, processes vision, and publishes motor commands. Two PID control DC motor plus a rear caster deliver the balance between agility and stability the curves demand.
For the system architecture, our software pipeline has 5 layers. The first one is the camera input, in which we use the raw camera frames. Then we have a custom YOLO V8 model that spots 7 traffic sign classes. Then we have a PID line following node that smooths the lateral error. Then a behavior tree state machine, which decides whether to drive, slow, to turn, or to stop. Then for the motor controls, we have the twist messages that activates the wheels.
To keep the robot center, we filter the robot signal with a median window and tune the derivative term to time oscillations. Here we can see a diagram that first we have an original image that we rotated 180 degrees to extract, and then we extract the region of interest. We pass this image now to a grayscale and Gaussian blur for a better process, and then we have a threshold and a global threshold. Then we applied an edge detections. Then in this case, we applied a canny edge detections, and then we pass it to an erosion and dilations to finally pass it to connect components and filtering to pass it to the machine.
We trained a custom YOLO V8 model for traffic sign detector and developed an HSV segmentation to track the colors of the traffic lights and keep track of 50 consecutive frames to avoid false detections. Our algorithm also translated detections into commands: stop, turning, or following the line.
Our state machine built with pi trees and includes 7 states: following in line fast, which is the default, following in line slow, stop, turn left, turn right, forward, and idle. Detections trigger transitions. For example, a yellow light activates follow line slow, and red light or stop signs it to stop. And turn or forward actions are executed once before resuming line following.
Our last tutorial produced an 82.4% lead tracking score and an average life of 1 minute 50 seconds for 5 runs. The assigned attention, if a 1 above 0.9, that place in a solid inside to competition top.
This is team number 1, Puzzlebot, the autonomous car we've been working on. As an autonomous car that currently identifies the red light of the traffic signal, and when it turns green, it moves forward and begins to follow the black lines. When it detects that there is no black line at the intersection, it uses vision to detect the signs. We can see that it continues moving forward thanks to the detection of the forward sign. Once it sees the black lines again, it resumes following them and continues its path. Later, the camera can see from a distance that the black line ends and the bot reaches another intersection where it detects a right turn sign. As a result, the Puzzlebot makes a right turn even if it doesn't find black lines. Finally, after making the turn, the robot continues following the black lines, and upon identifying the stop sign, it comes to a halt, successfully completing the course with all signs properly identified.
This project worked because we played our strengths. Jordan, Jesus, and Juanjo wrote a modular Python nodes. Ruben and Victor handled hardware integration. Hugo Knight spent nights turning parameters and regression testing. On the track, continuous integration on Jetson and daily retrospectives, accelerated debugging, and keeping moral high. Thanks for watching. The Puzzlebot team is eager to refine obstacles avoidance, share our code openly, so feel free to ask any questions or offer free feedback.